Okay, AP Pre-Calculus students, let's get going on 2.6, competing models from data. And we're going to be looking at different models and different data regression models today. So first thing what I want to do is start off, and you can pause the video, but I want you to fill these in real quick. And when it talks about regression models, these are all the ones that we're talking about today, but this is any functions that models today, the data. So this is a function that models the data, and this is an example of a regression, a linear regression model. Okay, so actual values, data that you collect, that's what the actual value is. Predicted is when you have a regression model and you plug the X in and you get a Y value. That's predicted. Residual, this is something that's probably new to you, but residual is the distance an actual point is from what our function of regression. This needs to be our line of regression for this one. This will be a negative residual, This will be a positive residual, and so on. This one is negative. A residual graph, we'll see an example of this, but it takes, on a linear one, it's really easy to see because it will take it and let it come down here. And if all of these were attached with these little blue lines, those little blue lines would all move with it, and that's what a residual graph looks like. We'll see that later in the lesson. All right, so the next thing that's in here is more about residuals. And again, you can fill this in. A regression equation can be called a model. The predicted Y value for a particular X value is the Y value given by the regression equation after you plug in that X value. The actual value, it's from either from a data table, or it's from information that you collect. All right, so the residual is found by the actual minus the predicted. This may be called the expected, or the actual may be called the observed. And it's very hard to say that, observed. Okay? If a point's directly modeled, here you go. And I did less than on this, greater than on that. You can pause this, get those filled in. Now the next thing we're going to do is look at this first example. In our first example, we have a table given to us, and this is 5 babies randomly selected from a pediatrician's office. We have a 4-week-old, 5-week-old, 6, 8, and 12-week-old. And what we're going to do is we're going to plug this information into our calculator. Now, what does it look like to plug it into the calculator? Well, you go to Stat, and let me see if I can get this a little bit better view so you can see what I'm doing. I hit Stat and 1 Edit, and I entered all of these values are entered right here on L1 and L2. This became my L1 information. This is my L2. By the way, this is the actuals because it's what's given in a table or what is observed. Okay, so I've got it entered, and it said write an equation of a linear model. Okay, so that means I need to go back to Stat and tell it to calculate a linear regression. I don't care if you use 4, 8. 4 makes my teacher heart happy, and because I've seen these for so long, yeah, it just makes me happy to use that one, so I'm going to. Okay, now I'm going to alpha F4. I'm going to store this information in Y1. If you do not do this, the regression, you cannot do a regression, not a regression, a residual graph. I'm going to find myself saying that often. Okay, so enter into Y1, calculate, okay, it's there. All right, now that I have this, I can go over here and I can write my model. So Y equals 0.185 X plus, actually I'm using T. I'm going to go back and fix this. and I'll show you why. 3.545. This is given in W of t, so I should be using a t instead of the x. In my calculator, it will say x, but that's not a problem. Now, to find the predicted weight of a 5-week-old baby, there's 3 ways to do this. One way is the good old-fashioned way. W of 5 equals 0.185 times 5. So the calculator in your phone would do this. 3.545. It would do this piece of it. So I can plug that in and get a value. Or I can go to second table, and I have all of my values right here, and I can see that 5 is 4.47. 4.47. So I have that amount, all right? And then it says, what's the residual? Now, I don't care if you do it this way or you plug it in with y of 1 of 5 to get the same answer, 4.47. The residual of a 5-week-old, remember this is actual minus predicted. So this is your actual right here for a 5-week-old, 4.4, minus the predicted 4.47, which is a total of negative 0.07 or 0.07. Interpret the meaning of this in context of the problem. It means that this 5-week-old is 0.07 kilograms lighter than what was predicted. So the weight of this 5-week-old baby is 0.07 kilograms lighter than expected. And I notice I'm writing all of this out of view. Expected. The other way it could be said, just so you know, there's 2 different ways to look at it. You could also say the expected weight was 0.07 kilograms more than expected, than actual weight. Okay, more than the actual weight. I don't have room to get it in there. All right, so a baby that at 7.5 weeks old has a residual of 0.7. That is a lot on this scale because nothing came out that big. That was a really big difference, but that's okay. We would say negative 0.7 because the residual is equal to actual minus predicted. We don't know the actual. Actual minus, now the predicted I can find. We need to say over here, predicted is W of 7.5. Now I'm going to do that in a calculator real quick, find that. The way I'm going to do it, second quit, I'm going to tell it to do alpha, calculate 1 of 7.5, and I got 4.9325. 4.9325. Now, to finish this out, I just need to do this small bit of algebra and say, let's add this value to the negative 0.7, and I get actual equals 4.2325 kilograms, and bless second period's heart, I couldn't write that right to save my life. I kept hearing it wrong. Okay, so once we have that, we have the actual weight because we knew the residual. Okay, so that wasn't bad. So what does this residual plot look like? Well, we're actually going to find this out. Now, I'm going to steal some of my information from up here. I did find out that the residual for 5, the residual was negative 0.7 because my predicted value was 4.47. Well, remember I have all of this in my calculator. I can go to the table function and I can see every last one of them. So if you need to pause this and steal my numbers, feel free to do so. I'm going to take them out of this calculator as well. So 4 is 4.285, and 6, 4.655, and 8, 5.0. Oops, 5.02. I just realized I was on the wrong line. Love it when I do that. Okay, let's get that off of there. Okay, and 12, 5.7. Okay, so then all I have to do is take this is the actual, this is a copy from above, just so you know. So take the actual minus the predicted, I'll get the residual. So now, just second quit. So I got 4.2 minus 4.285. Feel free to pause this, fill it in for yourself. I'm going to fill it in as quick as I can. Was that a 7.5 or a 2.5? And lastly,
pardon this interruption. We are going to be working through a test of our fire system.
Oh, lovely. I've got all of that going on while this video is happening. Okay, I've got all the numbers that I need. These are all the residuals. So I'm going to go over here and I will tell you I made this 5 cents, 10 cents, and 15 cents.
I want to let you know that we're in a real situation. However, what you'll be hearing will just be a test.
Oh, lovely. We get a test. Okay. That's what happens when you make a video at school. Things get interrupted. All right. Now I have to do a break in my line. And I don't care which way the diagonal goes, but now I can start this at 4, 5, 6, 7, 8, 9, 10, 11, 12. Now it all fits. So here I am with 4. And all I'm going to do is graph the residual plots. So think of 4, that's like 8.5 cents. So it's up here close to what? Oh, it was negative. Down here close to -1. Let's get rid of that one. Okay, negative 0.7. About there. It's slightly up, not by much. We'll make that one slightly bigger. 14.5 cents at 6. Yeah, it's pretty much on that line. And negative 7.5. Is that a negative? That's positive. 7.5 cents on 8. That's dead center of this. And negative 6.5 cents here. There you go. And we're done. Now, the only thing we have left to do in this video is to check the answer. So I'm going to show you how to graph that residual on here. So you've got that graphed. You can look at it. Now I'm going to go in here and show you what to hit. I'm going to get as much in view I'm going to lift this just a little bit so you can see more of my calculator. I don't know if you can see all of it or not. We'll see. So first thing I'm going to go do is turn on the second stat plot. I have to turn this on, so if it's not, I hit 1, make sure that is highlighted and it's on. Everything's on. Now I'm going to tell it to graph this equation. Okay, there's my equation graph. These are the points that I have. This is my line of best fit. Now I want to tell it to, this is how you get it to do, you go to edit. I want the residuals. So edit number 1, and I'm going to go over to L3. If that graph is not in the calculator, this will not work. Go up, hit L3, and we're going to insert a list into L3, second list. All of a sudden I have this number 7, and if you don't have the regression model entered into Y1, you will not have that number 7. So if you don't have a number 7, you don't have your regression model entered. So I'm going to hit 7, enter, voila, here's all of my residuals. Now to graph it. Second, plot, enter. Down here, I want it to graph L3 instead of L2 because L2 are my actual points. So I want it to tell it to do second, and I got to scoot this up so you can see it. My L3 is right here, L3. Enter. Now, it says L1, L3, and now I'm going to graph. Well, now when I graph, my line's up there, but I have these points down here. Well, why is that? Because remember how little we were. We went between negative 15 cents and 15 cents, so to speak. So if I'm there, I'm going to go back. There's a couple of ways you can do this. You can say zoom. And down here on number 9, it says zoom stat. So number 9, there it is. This is the residual compared to my residual, and you can see the points are very similar. All right? They just spread them out. It's zoomed in slightly. There you go. Okay? If you wanted to, you could make the window smaller. All right. End of this video. I'm going to finish. This was what we got done in class. Now for what we didn't get done on the next video. Well, maybe on the next